Hello, my name is Dr. Abrahimian, and in this channel I go over problem-solving strategies primarily in math competitions. In this video, I'm going to go over the convergence of an integral. Find all polynomials p of x for which the integral from 0 to infinity of cosine of p of x dx converges. So we're going to take a look at different possibilities for p of x, and then we'll solve the problem. Let's say p of x is a constant polynomial. So what does that give us? Integral from 0 to infinity of cosine of c dx. This is the limit as t goes to infinity of integral from 0 to t of cosine of c dx. And this would be cosine of ct. And when you take the limit of that, you either get infinity or you get 0. You could also get negative infinity, but in any case, this is convergent. So this converges if cosine of c is just 0. In other words, p of x would have to be pi k plus pi over 2, which is kind of a very obvious case. So if you have the integrand to be 0, then the integral is of course convergent. Let's look at a linear case. Well, the linear case, because cosine oscillates, we know that it would not converge. So this is going to be ax plus b. To formalize that, the integral from 0 to infinity of cosine of ax plus b dx becomes the limit as t goes to infinity. Integral of cosine is sine, and then we're going to have to divide that by a from 0 to t. And once we plug in t, we get something that oscillates. So we get sine of at plus b minus sine of b, which is just a constant all over a. And because this oscillates, this limit does not exist. Now what happens if the degree is more than 1? So let's say the degree of p of x is equal to n, and this is more than 1. So here's the technique we're going to use to solve this problem. If we use integration by parts, we would be able to bring the polynomial to the denominator, and any integral of this form, something like cosine of x over x squared, would converge. Why? I can't start from 0 because I have a 0 in the denominator, so I can start from 1 to infinity. This would converge because if I put the absolute value inside, this would be less than integral from 1 to infinity of 1 over x squared dx, which converges by p-test. So that means I can take the integral that I'm given, and I'm going to use integration by parts so that I can bring the p of x to the denominator. So here is what we're going to do. We're going to create basically a dv here. So this would be 1 over p prime of x times p prime of x cosine of p of x dx. So this would be the derivative of sine of p of x by the chain rule. So now I can use integration by parts. But before I can do that, I'm going to have to avoid zeros of the denominator. So I'm going to write this down as the integral from 0 to a cosine of p of x dx plus integral from a to infinity of cosine of p of x dx. And this a is larger than all roots of p prime of x, so that I can avoid the zeros in the denominator. Now clearly this one converges, so what I need to do is to check if the second one converges. So now I'm dealing with the integral from a to infinity cosine of p of x dx. So we get the integral from a to infinity 1 over p prime of x sine of d sine of p of x. And then when we use integration by parts, we get this is our dv, this is our u. We get uv 1 over p prime of x sine of p of x from a to infinity minus integral from a to infinity of v, which is sine of p of x times du. So I have to differentiate that. Derivative of that is negative p prime of x to the negative 2 times p double prime of x, all of that dx. Okay, so the first part converges this part because if you take the limit of sine of p of x over p prime of x as x goes to infinity, we get 0. And why is that the case? Because degree of p prime is at least 1. So this is going to be dominant in this fraction, and the whole thing becomes 0. And at a, we get some value, it doesn't matter. So now we'll have to look at this portion. So let's look at the second integral. So the integral from a to infinity of sine of p of x, and then divided by, we had p prime of x squared times p double prime of x dx. Now let's look at the degrees of this polynomial. Degree of p prime of x, p double prime of x is n minus 2. Degree of p prime of x squared is 2 times n minus 1, which is 2n minus 2. So if we look at the fraction of p double prime of x over p prime of x squared, the degree of this would be n minus 2 minus 2n plus 2, which is negative n. In other words, we can say this is less than or equal to some constant over x to the power of n. So now we are going to replace the integrand with this quantity. So the integral from a to infinity of sine of p of x times p double prime of x over p prime of x squared. We're going to show this converges absolutely. So we put the absolute value here, and this becomes less than or equal to integral from a to infinity. Sine is less than or equal to 1, so we can just replace it with 1. And this quantity of p double prime over p prime squared is less than or equal to x to the power of n times some scalar alpha. And this converges by the p-test because n is at least 2. So that means the original integral, so the integral from 0 to infinity of cosine of p of x dx converges if and only if p of x is either pi k plus pi over 2, which gives us the integrand of 0, or degree of p of x is at least 2. And that brings me to the end of this video. I will see you in the next video.